Here we're going to look at calculating a value of Kc. I've been given the initial moles of the acid and the ethanol, and I've been given the moles of the ethyl ethanoate at equilibrium. So again, we're going to set up a rice table. We've been told that we've got 1 mole of ethanoic acid, and I've got 0.5 moles of ethanol. And again, I'm assuming that I've got no ester or water at the start. I've been told that I've got 0.414 moles of ethyl ethanoate at equilibrium. So that's the information given in the question, and from that we can work out the moles at equilibrium, and then from then on we can work out the value for Kc. So this is increased, the change in moles is an increase of 0.414. We can see from the equation, for every mole of ethyl ethanol which forms, we also form a mole of water. So this will also increase by 0.414 to give me 0.414 moles at equilibrium. The equation tells me for every mole of ethyl ethanoate which forms, a mole of ethanol will react. So this will go down by 0.414. That gives me 0.086 moles at equilibrium. The equation tells me for every mole of ethanol which reacts, we also react a mole of ethanoic acid. So this will also go down by 0.414. That gives me 0.586 moles at equilibrium. So I've now got my moles at equilibrium. I'm now going to write a expression for Kc. And Kc is the concentration of the products divided by the concentration of the reactants. So that's my expression for Kc, and we can see here that we've been asked to look at concentrations. The Kc expression is the concentrations of the reactants and products, and we've been working out the number of moles. But in an example like this, where you've got the same number of moles of reactants and the same number of moles of products, so you can see I've got 2 moles of reactant, 2 moles of product, then we can use moles as well as concentration because the volume terms will cancel. So what we can do is we can put in my numbers. So I've got concentration, see the number of moles of the ester is 0.414 and the number of moles of water is 0.414, so that's 0.414 squared, divided by the number of moles of the acid, 0.586, times the number of moles of the ethanol, 0.086, and then Kc is 3.40. And there are no units there because, again, the concentration terms will cancel. 2 moles per decimetre on the top, 2 moles per decimetre on the bottom. I will stress again that in this particular example, we've worked out moles, but it's fine for us to put moles into my Kc expression because we've got the same number of moles either side of the equation, so the volume terms will cancel.